goes. Okay, so here is the discussion. So soils with similar properties may be classified into groups and subgroups based on their engineering behavior. Classification systems provide a common language to express concisely the general characteristic of soils, which are infinitely varied without detailed description. At the present time, we have two elaborate classification systems that use the grain size distribution and plasticity of soils, are commonly used by soil engineers. They are the Aashto, or the American Association of State Highways and Transportation Officials, no? And the USCS, or Unified Soil Classification System. The Aashto system is used mostly by state and county highways department or highway departments, no? So pag sinabing highways, pwedeng pumasok pa rin dyan yung mga engineers natin, no? May soil engineers pa din dyan. And then, whereas geotechnical engineers usually prefer the use of unified soil classification system, which is the mostly used, no? Ito yung pinakagamit talaga. When we say soil classification, mas gamit mismo yung, or mas pinaka-popular yung USCS, no? And then, there are numerous amounts of soil present in the surface of Earth, each containing of particles of different sizes, shapes, and compositions. And if we classify and categorize the soils, it will be convenient for us to study them. We arrange the soils into different groups such that soils in a particular group have similar behavior, no, or engineering behavior. And that process of arranging of soils is what we call a soil classification system, no? So i-arrange natin mismo yung mga soil grains natin. And any classification system must provide us the information about the expected engineering properties of a soil. And yes, of course, we still need to do a detailed soil investigation and testing. No, dahil yun talaga yung dapat, no, for the complete knowledge of engineering properties of soil. But classification system provides us an idea about soil's engineering behavior, no? Siyempre yung ating soil investigation, medyo mahal yun, no? So bago natin i-conduct yun, kung hindi natin magagawa yun, pwede natin gamitin yung soil classification system, no? So mas detailed lang nga yung ating soil investigation dahil actual sa field yun, no? Pero kapag, what do you call this one? Soil classification system more on laboratory use, no? And as stated a while ago, we have two classification systems that are adopted by the engineering agencies, no, especially in US, and that is the USCS and Aashto, no? Pero magdi-discuss din tayo ng iba pang system, no? Kaya nga dito nabanggit triangular text chart, no? Dahil sa board exam, itong tatlo mismo ang mas na itatanong, no, regarding Aashto, USCS, and the triangular text chart. When we say triangular text chart, that is by the use of the agency of USDA, no, or United States Department of Agriculture. Mas gamit lang nitong triangular text chart na to when classifying soils, or when classifying agricultural soils, no? So, before we classify them, since kailangan mismo yung particle size distribution to know the percent passing or passing percentage of the soil, we need to conduct mechanical analysis of soil, no? Ano ba yung mechanical analysis of soil? That is the sorry. That is the determination of the size range of grains present in a soil expressed as a percentage of the total dry weight or total dry mass. We have two methods that are generally used to find the grain size distribution of soil. First one, the sheaf analysis, and the second one is the hydrometer analysis. Yung sheaf analysis, mas gamit siya kapag medyo granular yung soils natin, no? Pag may yung mga grains ay larger than 0.075 millimeter in diameter, no? Yung hydrometer analysis naman, mas gamit siya kapag silty or clayey yung soil or more on fine aggregates, no? Sa sheave analysis, more on coarse aggregates tayo, no? So for the sheave analysis, that is consists of shaking the soil sample through a set of sheaves that have progressively smaller openings. The current size designation for US sheaves uses 100 millimeters to 6.3 millimeters. So yan mismo yung current size designation. No? When we say size designation, yung sheaves na ginagamit natin, ang tawag na sa kanya ay yung size mismo ng openings ng ating sheaves. No? Kunyari sasabihin doon, gagamit tayo ng 100 millimeter na opening. So, ang kailangan nyo ay yung 100 millimeter na sheave. Dahil yung sheave ay nakadesignate through its current size. No? Through its size or opening ng sheaves natin. Parang ito, kung pag sinabing sheave analysis, sa construction po pwede natin siyang maihalan tulad sa, may sheaving din tayo sa construction eh. Eto na-discuss ko na rin to sa inyo. Meron tayong ginagamit sa construction yung kulay green. No, yung iba naka-wire. No? Kapag gusto nating magpalitada and then yung buhangin na na-order natin medyo mabato. No? So, sinishield natin, no? Sinasala natin para makuha natin yung mas maliliit na particles ng buhangin na kailangan natin gamitin sa pagpapalitada. No? Dahil ayaw natin yung mga medyo malalaki yung grains na bato. No? So, most probably ganun yung kanyang principle. No? Kaya lang dito, a set of sheaves. No? At saka hindi natin gagamitin yan. No? Ang itsura ng sheaves na yan, ganyan mismo. No, nakaset siya. Papansin nyo dito, ilang sheave yung nandyan. No? Ito yung tinatawag nating sheave shaker. Na kapag in-on natin dito or in-start natin yan, kapag nakasaksak na, automatic na aalugin nung sheave shaker yung ating soil na nilagay dito sa set of sheaves natin. So kapag naalog yan, yung soil na nilagay natin sa taas, bababa. No? Depende sa kanyang diameter. Siyempre, yung ating sheaves dyan, may mga openings. Kapag mas maliit yung soil grains sa openings ng bawat sheaves, syempre papasa siya doon, no? Or lulusot siya doon. Until such time, papasok siya or makakarating siya kay bottom part. No, yung bottom part is what we call pan. Wala nang sheave dyan. No? So, na yung pinaka last part. No? Then, itong sheave shaker, ito na nakakalas to, yung upper part dyan. No, so dapat ito naka-sealed ng maayos, no? Ito po pwedeng itaas yan, po pwedeng ibaba yan. So pag binaba mo, dapat compacted mismo yung set of sheaves natin. Dahil kapag umalog yan, once na umalog yan, matatapon mismo yung lupa na nilagay natin sa sheave kapag hindi maayos yung pagkaka-compact, no? Or pagkaka-sealed ng ating part natin. No? Dahil kapag inalog mo yan, medyo malakas yung pagkaalog niyan. No? See, it is very unfortunate for us or for you na hindi nyo ma-experience yung ganito. No? Ito yung mga pinakamasayang gawin sa laboratory. And then, we have the second one, the hydrometer analysis. Hydrometer analysis is based on the principle of sedimentation of soil grains in water. When a soil specimen is dispersed in water, the grains settle at different velocities, depending on their shape, size, and weight. For simplicity, it is assumed that all soil grains are spheres, and the velocity of soil grains can be expressed by the Stokes law. So for the hydrometer analysis, it is also called sedimentation analysis, no? Because it is using the principle of sedimentation. And it indirectly gives the amount of soil that is still in suspension. No? So, meron tayong hydrometer dyan. Etong hydrometer analysis po pwede rin gamitin para malaman yung specific gravity ng mga soil grains na ilalagay natin dito. No? Siyempre, kung mas magaan yung lupa or mas maliliit yung particles, kung may tubig tayo dyan, magsisettle sila sa ibabaw, no? Pero kapag yung mga soil grains natin ay medyo mabigat, mas malalaki yung particles, mas magsisettle sila sa ilalim. No? So, and by that process, we can determine the density or specific gravity ng mga lumulutang na yan. At once na determine natin mismo yung density, we can now determine the diameter or the corresponding diameter of these soil grains. No, that is the principle of hydrometer analysis. And then, eto na. We have here a table regarding the US standard sheave sizes. Kanina, meron tayong nabanggit doon sa sheave analysis, the current size designation for US sheaves uses 100 millimeters to 6.3 millimeters. That is size designation. No? Sabi ko kanina, kung ano mismo yung openings ng bawat sheaves na yan, yun na din yung tawag sa sheave na yan. No? 100 millimeter sheave, 6.3 millimeter sheave. No? So size designation. Ito namang table na to, sheave number designation. No? So kung kailangan mo ng 0.053 millimeter na openings, hindi yun yung designation niya, hindi yung size ang designation niya. Naka-designate by its number. No? Lang yung pagkakaiba nun. Yung kasi nga mga part na to, itong mga sheaves na to, medyo maluluwang na to. No, 100 millimeters and then 6.3 millimeters. Ginagamit usually kapag granular yung soils natin. Pero kapag eto na, medyo malilit yung particles na to. No? So, eto, hindi po yan binibigay sa board exam. No? Bawat sheave number, you need to memorize its corresponding openings. No? Dahil may mga questions sa board exams and also in your examinations, na sheave number lang yung ibibigay. No, ang kailangan natin ay yung openings ng bawat sheaves para ma-determine natin yung diameter ng mga particle size natin. So each sheave numbers, you need to familiarize yourself kung ano yung openings niya. No, actually, kokonti pa yan. No, meron pang, wala lang akong ma-search. Kung yung sa book sana, I don't know kung meron kayong book ni Brahadas. may katuloy pa yan. No? And then, ito na yung sheave shaker natin. Okay, so once na-determine na natin mismo yung particle size distribution, malalaman natin mismo yung passing percentage in each sheaves. No? And then, after that, we can now determine the basic soil parameters which can be of great help in classifying the soil. No? And that is the effective size, uniformity coefficient, and coefficient of gradation. No? First one, anong effective size? That is the diameter of soil grains pertaining or corresponding to 10% passing or 10% finer. No? That is denoted as D10. That is the diameter of soil or soil grains corresponding to 10% passing. No? And then we have the uniformity coefficient. That is defined as the ratio of D60 with respect to D10. No? Or D60 over D10. Or that is the diameter of soil corresponding to 60% passing divided by the diameter of soil corresponding to 10% passing. No, that is uniformity coefficient. And then we have another one, coefficient of gradation, that is also called coefficient of curvature, denoted by the symbol CC. No, ito na yung formula niya, D30 squared over D60 times D10. Yung D30, that is diameter of soil grains corresponding to 30% passing. No, etong mga CU or CC na to, or uniformity coefficient and coefficient of curvature, they are measures of gradation of soil. No, and this helps to classify the soil, sabi ko nga kanina. No? So para malaman natin yung grade o yung particle diameters natin, we need to get the value of CU and CC. No? Anong indication nito? Kapag nalaman na natin yung CU, kapag daw yung uniformity coefficient will fall from a range 4 to 6, malalaman natin na well-graded yung soil natin. Ano bang ibig sabihin ng well-graded na soil? Pag sinabing well-graded na soil, that means that the mass consists of soil particles of different ranges or sizes. No? Ang ibig sabihin lang nun, No, it is pertaining to this graph. Yung naka-blue line, no? Yung graph number 2. Kapag ganyan yung mismo yung graph, that is what we call well-graded soil. No, mapapansin nyo dyan, bawat passing percentage natin nagko-consist ng diameters. No, ibig sabihin, merong 1 millimeter na diameter na lupa yung tinetest natin, merong diameter na 0.5, meron siyang diameter na 0.2, meron siyang diameter na 0.1, no? And then in between these sizes, no, kaya well graded, no? And then, paano naman kapag yung uniformity coefficient daw ay nag-fall less than the value of 4? No? Pag less than the value of 4, that will be known as or called as poorly graded or uniformly graded. Sorry. Uniformly graded. No? I think hindi lang ako sure ha. Poorly graded ata kapag yung CU is from 2 to 3. Pero kapag 1 na or less than that, that will be uniformly graded. No? Anong ibig sabihin ng poorly graded na soil? Pag sinabing poorly graded na soil, it is represented by the graph 1, yung gray. Yung gray na line. No, itong gray na line na dyan is what we call poorly graded. Ibig sabihin, kokonti lang yung size range ng lupa na yun. No? Mapapansin nyo from this part up to this part only. No, yung size range niya from 0.05 to 0.5 only. Compared sa blue line kanina na well graded. Yung size range ng ating mga particles ay from 0.02 to 1 millimeters. No, so sa poorly graded, kokonti yung size range na nandun sa lupa na yon. No? And then we have also here the black line. No, yung black line, that is what we call gap graded. Gap graded. Bakit gap graded? Merong gap. No, once na i-graph natin mismo yung correlation ng grain size and then yung passing percentage, merong gap sa graph niya. No? Ang ibig sabihin lang nun, dito, pasin yung parang pa straight line na dyan na part. No? Ibig sabihin lang nun, it contains size ranges from this part to this part. No? And then, dito sa part na to, sa pa straight line na yan, wala na siyang size range dyan. And then, i-continue niya from this part to this part. Kaya tinatawag na gap graded. No, within this medyo pa straight line na graph, walang diameters or walang particle size na 0.1 or 0.2 to 0.05. No, kaya gap graded. No. So, yan yung ating uniformity coefficient, coefficient of curvature, and then effective size. No, dito naman kay CC, kapag 1 to 3, that is well graded. No, parehas lang yan. Kung pwede tayong base kay uniformity coefficient, pwede tayong mag-base kay coefficient of curvature. No? When the coefficient of curvature falls from the range of 1 to 3, well graded siya. No, kahit na hindi natin ginagraph mismo yung correlation ng particle size and then yung passing percentage. No? Pero kapag yung CC is less than 1, but it is greater than 3, tama ba? Less than 1 but greater than 3, tama? That is what we call poorly graded. No? Let's have another one. So dito tayo magka-concentrate, no? Let's discuss the Aashto classification system. So the Aashto classification system was developed in 1929 as the Public Road Administration classification system. It has undergone several revisions, with the present version proposed by the Committee on Classification of Materials for Subgrades and Granular Type Roads of the Highway Research Board in 1945, and that is ASTM test designation D3282 or Aashto method M145. No? And then the Aashto classification system in present use is given in the table below. Nasa yung table below. Ito yung tinatawag nating Aashto classification system table that will be used in classifying the soil. And then, according to this system, soil is classified into 7 major groups. A-1 hanggang A-7. No, kung titingnan natin mismo yon, A-1, A-2, A-3, nandito yung A-3, nasa gitna. And then, A-4 hanggang A-7. No? So basically, kung ano yung nandito mismo, pinapaliwanag niya lang yung table, no? So yung principle ng Aashto classification system, it is summarized in the given table of Aashto, no? And then, sabi dito, soils classified into groups A-1, A-2, and A-3 are granular materials, where 35% or less of the particles pass through number 200 sheave. No? Yung number 200 sheave, merong opening yan na 0.075 millimeters. No? Sabi ko nga, mas maganda na memorize nyo yung openings ng bawat sheaves natin. Dahil etong openings na to, yan yung kailangan natin para ma-determine natin yung size ranges. No? And then pag sinabing A-1, A-2, A-3, mas magagandang klase yan when it comes to highways and roadways. No? Dahil granular materials yan. No? Pag granular materials when it comes to highways, that will be of good quality. No? And then soils were more than 35% passing through the number 200 sheave. They're classified into groups A-4, A-5, A-6, and A-7. Kaya nahati yung table natin, no? Sa dalawa. Etong upper part, that is A-1, A-2, and A-3. Granular materials yung tawag doon. Yung mga lupa na nag-pass through kay number 200 sheave na dapat daw ay 35% and below. No, yung passing percentage. Yung nasa ilalim naman, they are what we call fine particles. No, or the silt clay materials. And then that is more than 35% ang nag-pass through kay number 200 sheave. So, pag more than 35% ang nag-pass through dyan, ibig sabihin, madami yung kanyang maliliit na particles. No? So, kapag madami yung maliliit na particles, hindi siya granular, no? More on silt or clay material siya. No? And then mapapansin nyo dyan, yung subgrade rating niya, fair to poor. No? So, eto, hindi masyadong maganda yung quality kapag A-4 hanggang A-7. Yung una, pag granular materials, excellent to good yung quality niya. No? So, mas gamit mismo yung mga groups na to, A-1, A-2, and A-3 in highways and roadways, no? As a subgrade material. Alam niyo naman na siguro yung subgrade, di ba? Dahil meron na kayong highways, no? That is a part of highway bago natin i-construct. And then, balikan natin yon. For the grain size, we have here gravel. Malalaman daw natin gravel mismo yon, depende sa grain size. And they are fraction passing the 75 millimeter sheave and retain on the number 2 or number 10 or 2 millimeter sheave of the US designation. No? And malalaman nating sand particles yun kapag yung size ranges magfo-fall from 0.075 millimeters hanggang 2 millimeters. No? And then malalaman nating silt or clay material yun kapag mas maliit kay number 200 sheave yung diameter ng lupa or mas maliit sa 0.075 millimeters na opening. No? So yan, kahit hindi mo na-memorizean, no? Magbase lang kayo dito sa table na to. No? Ang in-explain lang doon ay yung Aashto. Ito lang daw. No? Kapag daw clay materials, dapat less than 0.002 millimeters yung diameter ng lupa. And then kapag silt materials, dapat 0.002 hanggang 0.075 millimeters yung diameter. Kapag sand particles, dapat 0.075 millimeters hanggang 2 millimeters yung size range. And then kapag greater than 2 millimeters, that is what we call gravel. No, dapat hanggang, ito medyo typo lang tayo dito, hanggang 75 millimeters. No? Dahil kapag greater than 75 millimeters, hindi na gravel yung tawag. No? That will be called as boulder or cobblestones already. No? Medyo malalaki na yun, di ba? Pag sinabing boulder rocks, medyo ang laki ng particles na yun. No? So that should be greater than 75 millimeter in size range. No? Ito, memorize nyo din to. Dahil sa examination or board exam, depende kung ano yung agency na pinapatanong. No, dito nagbase lang tayo kay Aashto. Pwede rin tayo magbase kay MIT and then USDA. No, MIT or the Massachusetts Institute of Technology, nag-iba yung size range. No, yung clay materials halos parehas pa rin kay Aashto. Sa silt, medyo nag-iba, no? From 0.002 millimeters hanggang 0.06 millimeters. Yung sand, 0.06 millimeters hanggang 2 millimeters. And then greater than 2 millimeters, that will be called as gravel particles. No? And then kapag USDA naman or United States Department of Agriculture, yan yung size range. No? Pertaining to gravel, sand, silt, and clay. Kapag USCS, Unified Soil Classification System, kaya sinabing unified dahil it is composed of different agencies. No? So, meron diyang US Army Corps of Engineers, Bureau of Reclamation, and then ASTM, American Society for Testing and Materials. No? So, nagsama-sama yung tatlong agencies na yan. And then, that is, kung ano mismo yung study ng bawat agencies na yan, kinombine nila and then, nag-come up sila sa isang classification system. And that is what we call USCS. No, sa USCS, wala tayong tinatawag na silt at saka clay. Dahil pinagsama nila yung silt material and then clay particles. And they are what we call fine particles. No, nakapag less than 0.075 millimeters daw yung size range, malalaman natin na or makaklasify natin na siya ay fine particles. No, dito naman 0.075 hanggang 4.75 sand particles, 4.75 hanggang 76.2 gravel particles. No, eto napakahalaga to. Kailangan yung i-familiarize yung sarili nyo dito. No, hindi rin yan binibigay sa board exam. And then, next one, we have the plasticity. The term silty is applied when the fine fraction of the soil have a plasticity index of 10 or less. No? And the term clay is applied when the fine fractions have plasticity index of 11 or more. So, dyan pa lang kapag nalaman na natin plasticity index, you can now classify the soil. No? If it is a silty soil or a clayey soil. No? Actually, itong mga terms na to nakapaloob kay table, no, lahat. No, so for the evaluation of the quality of a soil as highway subgrade material, a number called the group index or GI is also incorporated with the groups and subgroups of the soil. This number is written in parentheses after the group or subgroup designation. The group index is given by the equation, medyo mahaba lang po, that is F minus 35 multiplied by the quantity 0.2 plus 0.005 multiplied by LL minus 40. No, plus 0.01 multiplied by F minus 50 multiplied by PI minus 10. Nandito na yung designations, no, ng mga parameters. F, that is the passing percentage kay number 200 sheave. LL is the liquid limit and PI is the plasticity index. No? So, eto, kailangan yung i-memorize din yan. No? Na kapag yung GI daw, yung group index that is indirectly, no, or inversely proportional sa quality ng soil. No? Na kapag mababa daw yung GI, maganda yung quality. No? As subgrade material. Pero kapag mataas daw yung GI value, mababa yung quality. No, it is inversely proportional. GI is inversely proportional to the quality of soil as a subgrade material for highways. No? Kaya pa ganyan mismo yung relationship natin. And then we have here, kailangan nyo ring i-memorize to, the following rules in determining the group index value. No. So, if group index GI yields a negative value, it is taken as 0. So that means the lower limit for group index is 0. Hindi po pwedeng lower than 0 or hindi po pwedeng maging negative yung value niya. And then, the group index calculated from above equation is rounded off to the nearest whole number. So, naka-whole number po palagi yung value ni GI. No, for example, 3.4 magiging 3. 3.5 magiging 4. No? So, paano kapag 3.49? Anong GI niya? Paano kapag 3.49? Anong GI niya?
4 po.
4 ba? 3 pa din, no?
3 po.
3.5 po dapat 5. So, pag hindi siya nakarating doon, that is round down. No? Yung iba kasi ginagawa, yung 4, may round off, magiging 5, and then gagawing 4. No? So, titinan talaga ay yung katabi, no, ng whole number, yung sunod, yung tenths. And then, there is no upper limit for the group index. So, kahit na 1 million yung value, okay lang. No? Basta positive. Wala tayong upper limit value of group index. No? Just take note, ang lower limit ay palaging 0. And then, ito napakahalaga din, the group index of soils belonging to A-1-A, A-1-B, A-2-4, A-2-5, and A-3 is always 0. No? So kapag nag-fall tayo sa mga groups na yan, no need to compute GI. No need to use this equation. No? Automatic na ang GI ay 0. No? So, laging tatandaan yun. And then, number 5, rule. When calculating the group index for soils that belong to group A-2-6 and A-2-7, use the partial group index for plasticity index or etong equation daw. No? Kapag A-2-6 at saka A-2-7, yung naka-add lang dyan, etong nakahuli. Yun lang yung gagamitin nating formula. Eto, exclude natin yung naunang term. No? And then, kapag hindi nag-fall sa mga groups na yan, gagamitin natin yung buong equation. No? Etong group index formula na to, saan na yun? Etong group index formula na to, mas gamit sa A-4, A-5 hanggang A-7. No, yung mga fine particles, yan na yung group index value or formula to be used. And then, eto kahit hindi naman na aralin to, no? Ito ay nakasummarize din sa table, no? Anong ibig sabihin lang ng table na to? Ibig sabihin kapag daw yung plasticity index, ito ay PI, di ba? It is a table correlating the value of liquid limit and plasticity index. No? That is what we call plasticity chart for the Aashto table classification system. No? Na kapag daw yung plasticity index ay 10, malalaman na natin mismo yung symbols or groups natin. No, 10 and below, that is A-2-4, A-4, A-2-5, tsaka A-5. Pero 10 and above, or above 10, ito yung classification, no? A-2-6, A-6, A-7-6, A-2-7, then A-7-5. No, ito namang vertical line na to, kapag daw yung liquid limit is 40 and below, ito yung mga group symbol. Pero pag above 40, ito yung mga symbols. No, meron din tayong slant line dyan. Itong slant line na yan po pwede natin kunin yung equation. No, ito may point dyan, di ba? Ito may point din doon. Tama? Ano yung point na to? Kapag ito yung liquid limit, ito yung plasticity index. Ano yung point na yan? Meron siyang liquid limit na 100, meron siyang plasticity index na 70. Di ba? Etong point na to, meron siyang liquid limit na 40, meron siyang plasticity index na 10. No? Therefore, we can compute this equation of a line. Ano ba itong equation ng line na to? It separates A-7-6 tsaka yung A-7-5. No? By the use of this line or by the use of the equation of this line. Ano ba equation na yan? So, ratio and proportion lang tayo, di ba? Straight line yan. So that is LL minus 100. That is, para mas madali, ito, tsaka ito. No? So that is LL minus 100 and then 100 minus 40. Equivalent to PI minus 70 over 70 minus 10. No? So ano yan? LL minus 100 divided by 60, di ba? 60 to, di ba? And then 60 din to. So canceled. So equivalent kay LL minus 100 equivalent to PI minus 70. So eto, lipat mo laang sa kabila. So malalaman natin na yung plasticity index is equivalent to LL minus 100 ilipat mo plus 70 minus 30. That will be the equation of this straight line. No? Na kapag daw yung plasticity index is equivalent or less than that, dahil pababa yan, equivalent or less than that, LL minus 30, A-7-5. Pero kapag daw yung plasticity index is greater than LL minus 30, that will be classified as A-7-6. No, yan ang ibig sabihin ng table na to. Ngayon, yung mga principles na yun na binanggit natin, it is summarized in this given table. No? So, yan na yung table na gagamitin natin. So, kailangan natin dito yung passing percentage na number 200, passing percentage na number 40, tsaka number 10. Also, the value of liquid limit and plasticity index. Yun lang, yung kailangan natin para ma-classify natin yung soil. We normally start with number 200. So from the passing percentage of number 200, it's either pababa or pataas yung process or pababa yung process. No? Kapag pataas yung process, it will be classified as A-1 hanggang A-3. Pero kapag pababa, from number 200, papunta kay liquid limit tsaka plasticity index, it will be classified as A-2 and then yung nasa ilalim. No? Hanggang A-7. No? Ito na yung sinasabi kanina na kapag daw yung plasticity index is 10 and below, pinaka-maximum daw yung 10 na value ng PI, that will be termed as silty soil. Pero kapag above 10, no, or 11 minimum, kapag sinabing 11 and above, no, that will be termed as clay soil. Ang ibig sabihin kasi ng minimum, pinaka-minimum yung 11, no? And then kapag sinabing 10 max, pinaka-maximum yung 10 na value. No? So, yun na yung sinabi kanina. Okay, so, that is Aashto. Ito naman na yung line na dinerive natin kanina. No? If it is less than or equivalent to LL minus 30 yung PI. Para ihiwalay natin yung A-7-5 kay A-7-6. No? So, ito lang yung summarize ng mga principles na yun. So, ito lang yung titingnan natin later on para ma-classify natin yung lupa. So, that is Aashto. Next one, we have the USCS, or Unified Soil Classification System. For this system, it is first developed by Casa Grande, no? And later it was modified by the Bureau of Reclamation and the Army Corps of Engineers of the United States of America, no? And this system has also been adopted, no, by the ASTM, or the American Society for Testing Materials. No, ito yung pinaka gamit sa lahat. No, ito naman yung USCS table natin. No, iisa lang siya. Yung atin. So mag-uumpisa tayo dito from the right part papuntang left side ng table. No, hanggang sa marating natin yung group symbol. And then eto, kailangan din natin itong plasticity chart, no? Kung may plasticity chart kanina yung Aashto, may plasticity chart din tayo kay USCS, no? Correlating the liquid limit value and the plasticity index. No? Mapapansin niyo dyan, meron tayong tatlong lines. No? Etong vertical line na to. No? Kapag daw yung liquid limit will fall from 50, anong ibig sabihin nun? Ito yung tagahati. No? Kapag daw 50 and below, and then 50 and above, yan daw yung nagahati para malaman natin kung low plasticity or high plasticity yung lupa natin. No? Mapapansin nyo, hinahati yung L at saka yung H. No? So, 50 and below yung liquid limit, low plasticity tayo. Dito sa part na to. Pero kapag 50 and above yung liquid limit, high plasticity yung particles natin. Kaya H yung ginagamit dito sa side na to. No? And then meron tayong line dito. That line is what we call A line. No? Yung A line na yan, merong formula. No? Plasticity index is equivalent to 0.73 LL minus 20. Ano naman yung designation yan or naman yung role ni A-line. Yung A-line na yan, it separates the clay materials and the silt materials. Kapag daw nandito sa itaas ng A-line, clay materials yan. Kapag daw nasa ilalim ng A-line, silt materials. No, kaya mapapansin nyo C, yung ginagamit sa itaas ng A-line. No, pag sinabing C, clay soil. No, and then sa ilalim ng A-line, M, yung ginagamit. Pag M, that is pertaining to silt. No? Huwag kayo malilito doon na dahil may S, meron din tayong S for sand. No? Pero kapag sinabing silt, ang letter natin doon ay M. No? Pag S kasi, sand. No? So, silt, ay M. Kapag sand, that is S. No? And then meron pa tayo ditong isang line, U-line. Ano naman yung U-line na yan? That is the upper limit of the values correlating liquid limit and then plasticity index. Ibig sabihin, kapag nirelate natin itong dalawang ito, hindi siya magfo-fall above U-line. No? Walang points na pupunta dyan dapat, no? Above U-line. Hanggang dito lang yung upper limit natin. No? Correlating the value of liquid limit and plasticity index. So wala na, above this U-line, wala na tayong classification ng lupa dyan. No? So, dapat below U-line palagi. No, nandun lang yung mga classifications natin. No? And then, balikan natin to. No? Again, that is G. Pag sinabing G, gravel. No? Pag sinabing W, well-graded. Pag sinabing G, gravel. Pag sinabing P, poorly graded. Pag sinabing G, gravel. Pag sinabing M, silt. Pag sinabing G, gravel. Pag sinabing C, clay. No, S, sand. W, well-graded. Sand, poorly graded. Sand, silt. Sand, clay. No, dito naman clay yung C, yung L, low plasticity. M is silt. L, low plasticity. O, organic. No, organic yung soil natin. Ibig sabihin, madaming mga organic materials na kasama. No? May mga kahoy-kahoy, yung lupa natin. May mga remains ng mga animals. No? So may mga organic materials other than these soil grains. That is why it is organic. No? And then L, low plasticity. C, clay. H, high plasticity. M, silt. H, high plasticity. O, organic. H, high plasticity. We have also here PT. No, that is peat. No, that is highly organic soils. So medyo mas madami na yung organic materials niya kesa kay soil grains. No? And that is what we call peat. And that is primarily organic matter, dark in color, and organic odor. So, yan yung ating USCS table. No, so later on, malalaman nyo kung paano gamitin yan. Okay, so once na nalaman na natin mismo yung symbol, kailangan nating i-determine yung name. No? So bawat symbol, merong kaangkop na name. No? Depende mismo sa designations natin, no? Kung saan tayo magfo-fall. So lahat yan, no? Meron pa dito. So bawat symbol, merong kaangkop na pangalan. No? So you need to familiarize yourself with respect to these tables. No? Hindi po yan binibigay sa problem. No? Kaya ba yon? Siyempre hindi yun kaya, no? Kasi nga charos lang yun. No? Ito ay binibigay po sa board exam. Ang mga tables na to. No? Ito, mga yan, ibibigay dapat yung mga yan. No? Same with the Aashto classification. Okay, so para mas familiarize kayo dyan, wait lang ha. Hello, naririnig po ako?
Yes po.
Okay, so para mas ma-familiarize kayo sa mga systems na yon, let's have examples, no? So, first one, Aashto muna tayo. Ang dali lang to, guys. Procedural. Classify the following soils by the American Association of State Highways and Transportation Officials, or Aashto, classification system, and give